Alright, so hello and welcome. I believe we are live. Are we live? Hold on, I'm not sure if we're actually live. Presuming that we're actually live. Let's see. Yeah, I actually don't know. I have no idea. I think we're live. I think we are. Presuming that we're actually live. Howdy, hello and welcome. The idea is I'm going to try one more problem and make some food for myself, and then try one more problem, make food for myself, and then go from there. We are taking gratuitous breaks, right? Gratuitous breaks, a max point on a line. So this by the way, I don't know if you noticed that. Oh wait, I did it wrong. This has a 19% success rate, which means we're not going to get this right. 19%. Probably not gonna get it right. It's probably really hard. We'll try though. We'll try. So yeah, probably a hard one. But let's see how it goes. Let's find out. Find out how hard it is. I also I've just been taking like I said gratuitous breaks. I don't know, man. Just take a step at a time. You know, do just kind of keep it simple. Go slow. Don't need to try to be better than what I am. Something like that. Oh, you know what? This I was supposed to have. I made a mistake. I was supposed to have one of these open. Give me one moment to fix that. So what I wanted to say was that oh no, not what I meant to do. Okay. Yeah. So we'll see how this goes. What I wanted to say was, I forgot what I wanted to say. That's okay. We'll just focus on the problem. Given an array of points where points of I is equal to x sub I, y sub I represents a point on the xy plane, turn the maximum number of points that lie in the same straight line. Oh, that's interesting. Huh. Okay. Points 1, 1, 2, 2, 3, 3, 3 points. 1, 1, 3, 2, 5, 3, 4, 1, 2, 3, 4, 1, 4. 4. Oh. 300 points. And all the points are unique. Oh, this is a really interesting question. So this one is actually a curve fitting question, believe it or not. Oh, we gotta sit and think about this one. Ooh. This is a good one. This is a good one. Oh, okay. Let's ponder this. Let's ponder this. Uh-oh. Uh-oh. So here's the deal. What we could do is actually... Oh, my neck. There's only 300 points, so we could do this in quadratic time if we wanted to, potentially. And that would be for each pair of points, there is a line through those points. And you can check for each of those lines, which line has the most points on it. That would work. That's one approach. There's another idea, as mentioned, called line fitting, best fit line to the points. I don't think that's the best approach. One issue though with this, as I was saying, quadratic time algorithm to check, the problem with that is even though you can get all of the different possible points, my neck is, I'm trying to crack my neck, but it's not working. The checking that these other points are collinear with the line you've selected, we could do that in linear time, so you could get a cubic time algorithm, which actually isn't too bad. Cubic time should be relatively fast. I think we could just do this in cubic time. 300 cubed, 27 million. That might be a little slow, but it might not be. I mean, that could be okay. I mean, we could maybe just brute force this. Just take every pair of points, create a line, take all the other points, see if they're on that line. How many other points are on that line? I mean, yeah, that's one way. It's, I mean, sure, I suppose. You know what you could do also is, how about this one? This might be quadratic. You ready for this? Point slope form gives you a slope and a y-intercept. You can use the slope and the y-intercept as a key into a map, and you can take a frequency map of how many points, when you compare the 2 points, how many of them have that slope. So every pair of points, that'd be interesting. So if you took the first point and you compared it, so you could do it this way. You could dump all of the points into a set, an unordered set, right? And then you can say, all right, we're going to take a point and we're going to consider all the other points, so linear time, right? Take one point, consider all the other points, and we're going to group them all together, right? So if they all are on the same line, group them all together. And now what's tricky about this is that you could have points that are connected through multiple lines. Oh, now that's interesting. But group them around the point slope value. So hash them to that value. And then don't consider that particular point again. That might be why this got 20%. That might be why it got such a low rating, is because if you remove that point that's an intersection, the issue you're going to run into is that that point won't be counted properly. Oh, that's really interesting. Okay, that's really subtle. That's a tricky thing to work around that properly. I think I can get cubic time, but quadratic time is going to be tricky. I think you can do quadratic time, which is all you need. That's pretty fast. But the problem with the quadratic time is that you need to put you could take point slope form and show that 2 points are on a particular line. I guess what you would do is you could take 1 point and take point slope form for all of the other points with regard to that point, and you can say that all of those points are on that line, right? What might be better is actually to create a set of points at that point slope form, right? Instead of just gather all the points, because we don't have that much memory. We need to yeah, it's only 300 points, so you can gather all those points. And if you had intersections, I mean, you can't really have that many extra points. But basically, what can in memory, but what can happen is that you have a set of points for that particular point slope form, and then what can happen is as you take a look at other pairs of points, you would end up not adding the redundant points to your sets. Yeah, you could do it that way. I mean, that's fine. It's not linear memory. It's like technically quadratic memory, I guess. But it would be quadratic anyway. Excuse me. It would be potentially quadratic anyway if you had every pair of points if all the points were not collinear. So I mean, it's not a lot of points to work with. So we could do this like quadratic memory, quadratic time. I'm fairly certain. This is going to be interesting. But I think I'm not going to go into too much detail as to like what are some of the more what are like the better ways to look at this problem. How much time are we at? 10 minutes? Yeah, we'll just spend like 10-15 minutes. I don't want to go crazy. Excuse me, I don't want to go crazy on this one. There might be a better way to do this. It might be like a linear time algorithm, but we're not gonna go nuts here. So yeah, we're not gonna go nuts. So okay, so we're gonna do. You may not actually need to use extra memory for this. Now I'm thinking about it. Yeah, you could just say take 2 points. The first two, yeah, take 2 points. We don't need to do a round robin. Take 2 points, find the line, and no, we should do round robin actually. 2 points, create the line. You say those 2 points are on that line, and then every other point that's also on that line. Since they're on the same line, you could take either of the points. Yeah, you could do point slope form. You could do this quadratic time without any extra memory. I'm fairly certain. Yeah, because yeah, it's actually this is quadratic time. Yeah, it's pretty straightforward. It's actually really straightforward. You don't need to use any extra memory. I know what to do. You really could just do x or const auto a b points all the other points c d points. We just need to make sure it's not the same point. That might be easier just to use indices then. All right, so what we're going to do is we have int m 0 or negative. We'll do m. We'll do it this way. Bool set or unset equals true. Int m equals. So here's the tricky thing. Yeah, we can end up counting the same line multiple times, I think, which is tricky. There might be a way to do this in linear time, but for now we're going to do quadratic time. So m is 0, b is 0, and we're going to say unset is true. If I is not equal to j, we say if unset, then we're going to take calculate m and b using point slope form. So the way you do that is you take a point and you say y minus, we'll call it x sub 0, is equal to m of x minus x sub 0 minus x y sub y minus y sub 0 is equal to m times x minus x sub 0. So b is going to be, so m is going to be delta y over delta x, and oh, another reason why this is probably 20% is that m could be infinity, right? M could be straight up and down. Ooh, that's really tricky. Yeah, vertical lines. Oh, excuse me. Ooh, how do you deal with vertical lines? That's a challenging one. That's a challenging one. We'll come to that in a moment. That's like a special case. All the other lines are fine though, so we can say m is delta y over delta x, and then b is just going to be it's going to be y sub 0 minus m times x sub 0. Yeah, for a particular point. So we'll say int x equals I of j, or no, so we'll say points are, int x equals points of I of 0, y, and we do a, b, and c, d is probably easier for the 2 points. A, b, points of I, 1, c, and d. All right, so it's a, b, and c, and d, and now m would be, so unset is going to be false, by the way. B is going to be m times x0 plus b. Yeah, we do need to do something about whether it's vertical. Vertical equals false. M times x, so we could do a is x0, and it's subtracting m times a, so b, m enter, we could just say intercept instead of b. You can call this y too, yeah, that's fine. Okay, so we actually want to do this at each step, believe it or not. If it's unset, then we're going to set these two and continue. ABCD. Oh, it's not M and intercept. It's going to be, we'll call it alpha is M, and beta is going to be the intercept. So it's alpha times A, so negative alpha times A, and it's going to be B minus, and alpha is going to be delta y over delta x, and y is going to be B and D, so D minus B, or B minus D, over B minus D over A minus C. So delta y over delta x doesn't actually matter what the what's the word? If you swap the two with each other, it's still going to be the same slope. So it doesn't matter the order you calculate delta y over delta x. How are we doing on time? Yeah, it's not as easy as I make it out to be. This is definitely a really challenging question, even if we do it in quadratic time. So, all right. At the end of this, we're going to return ret. We could just write that now. But what we want to do is we have unset, we have vertical, we have calculating m and b using point slope form, or slope and intercept, slope and intercept, and you could call it, yeah, you can call it m, that's fine. Calling these two alpha, beta. So if it's unset, we're going to set unset to false. We're going to set ret equals standard, or current, we'll say. Int current equals 0. Current equals 2. So we have 2 points on the line. And then we're going to set unset to false. We're going to set m to alpha. And intercept to beta. Okay. Otherwise, if it's not unset, then we would say if it is set, then we can say if m equals alpha, and so now what's interesting is Yeah, one pass tells us all the points that are on the same line. And we're potentially going to run this pass over and over again. Now, one question would be, now the reason why you could end up running this, we're going to end up running this pass multiple times, we're going to be very careful here, is because if you say we're going to remove all the whole line, all the points of the line from consideration, the problem with that is there could be intersecting lines with the same points. If you remove those points, then those lines are going to be broken, or there's not going to be as many as there should be. So for now, we're going to go over all the lines, but it's maybe possible to just go over like I think part of the problem is that there actually is potentially a quadratic number of lines to consider. Yeah, there may be a faster way to do this. I just don't know it. There's probably a faster way, but like simple approach we can do. So now we have to handle the vertical case. We didn't handle that yet, but we have to do that. So if m is equal to alpha and intercept is equal to beta, collinear, and collinear I think has two L's. Excuse me, could be wrong. Then current plus equals 1, right? One of these points is new, the other one is not. Yeah, because they're all going to be matching against I, basically, all the other points against I. And I think that's it. I think that's all you got to do. You just say and then you set unset back to true. Right, now you're going to reset m and intercept again. They're collinear, you increment 1, and then also say ret equals standard max of ret and current. And I think that's all you got to do. Now, what if you... Now, okay, we need to check if things are vertical. So that's if A is equal to C, right? That's the delta x. So if there's no delta x, so vertical equals A minus C. So actually, if A is equal to C, and then we do something else entirely, if they're not equal, we can set alpha to this. We're going to set that just to 0. Could be vertical, I mean horizontal. So they're not equal. Otherwise, that v equals false, so v equal to true. If the main one is vertical. A is not equal to C, we can find alpha. Otherwise we set v to true. And we're going to say, so if alpha is basically infinite, beta doesn't matter either. So actually both alpha and beta neither of these can be calculated if we're vertical. So for unset, then m is alpha, intercepts beta, and we should also do vertical equals v. Unset's false. And then collinear if v, so if we're vertical, v and vertical is true. Now here's the deal. Excuse me. Part of the issue is if this is really tricky, so we should do it this way. If vertical or v, then we're gonna say if neither vertical nor v, then we can do the other one. So part of this is, it really is something like this. If you're vertical or v, if that's not the case, then you're neither of those, neither vertical nor v, right? Then you can check these two. But if you're vertical or v, but now part of the problem is that, yeah, that doesn't work. That's too much. That's too much logic in one piece. Yeah, if you're vertical or v, you need to check the following things. You have another if statement in here. Okay. There's like a whole logical, I think you can do this, but basically there's like a whole logical check. If you're vertical or v, and you say if vertical and v, and vertical and v, and the a is equal to, if it's vertical, m-intercept, and we could just say x-val. V equal to true, x-val is equal to so if v and x-val is going to be either a or b, it doesn't matter if it's vertical. This is x value. It doesn't really matter which of these you could do. This is kind of confusing. This is really confusing. V is true. This is actually the same for every value, by the way. For I, for j, this doesn't need to be modified multiple times. Yeah. So this is just C and D for j. Alpha, beta, vertical is true. You just have to check if it's vertical, then this value, this vertical value is set to A. Doesn't really matter. I think I'm doing this wrong, potentially doing this wrong, making this more complicated than it needs to be, but that's okay. We'll go from here. So vertical false, A is not equal to C, vertical true. If it's unset, so vertical to V. If you are vertical, then set x value to A. Actually, if you're vertical, you're really just checking A against X, A against C. That's all it comes down to. Yeah, if you're unset, you don't even look. I don't think you even use V down here. By the way, I don't think V is even necessary. or excuse me, V, you don't use V or vertical here. You only care if you're vertical. Then all you have to do is just check vertical and I can see why this could be really challenging though. 19% is really low, like abnormally low. I want to just try to get it correct, and then we'll work on like figuring out how to make this like more reasonable. So A is equal to C. Yeah, that's all you really need. You don't need V here at all, I think. Do you? Yeah, I mean, I guess you do. I don't know. So the problem is that if you're vertical and you're V, you want to go here, but if you're not vertical in V, right, you don't want to go here. You want to just, if you're not vertical, go here. So that's why it's this if statement kind of represents a few different things. Because you don't want to execute this at all if the thing you're looking at is not vertical. Now what's interesting is it's really actually you do want to use V here because you don't want to execute this code at all if you're either V or vertical. Yeah, in both of these cases. Because you could be vertical on this line, and then this comparison just doesn't make sense. Yeah. Basically, if it's not also a vertical line, it's definitely won't be correct. So something like this. It's a little bit complicated down here, but something like this should work. So I don't know, does this compile? I probably missed something. There's so many pieces involved here. I don't know. All right. It might be correct. It might be it. Wrong answer. Okay. What happened here in the bottom one? 1 1 3 2 5 3 4 1. So when we picked 1 1, we have that vertical line. We pick 3 2. Where's 3 2? 1 2 3 3 2. We compare 3 2 to all the other points. This line should be the same as all these other lines. The first one we pick, I guess, would be 5. No, yeah, 5 3. Oh yeah, that one. So we pick that line 5 3, and try to match everything against that line, and that doesn't work. Then we try 5 3. And try. So I think maybe what I'm doing wrong is I think what I'm doing wrong is I do need to actually create that set that I was describing before, because we're not going through all of the possible lines. That's kind of an issue. What we should be doing is, yeah, we can still do this quadratic time, but it's got to be, you take the 2 points and you create the slope, and then you hash that, the slope and the y-intercept, and you hash that to a point in the to a spot in a map, and you take the 2 points you just considered and put them in a set. If you do that, so how are we doing on time? 35 minutes. All right, we kind of slow on this one. If you do that, then every 2 points you can match them to that slope, no matter how you look at the points. The problem with this approach is that while you're grabbing 2 points and creating a line, and then you're looking at all the other points. Well, yeah, it's true that if you look at the first point, any of the ones that are on the same line. Yeah, no, I'm correct on this. I think I'm right on this. So 5, 3. You look at 5, 3, and so you say 1, 1, and look at the other points. 1, 1 to 3, 2, and no other points are on that line. Then you say 3, 2 to 1, 1. So you go 1, 1, goes all the way across, right? I is 1, 1, you go through all the J's. Then I is 3, 2, you go through all the J's again. So you go 3, 2 back to 1, 1 again, do the same routine. Then you go to 5, 3, and then start off at 1, 1. Maybe I'm wrong about this. I don't know. Somehow I feel like something's not quite right. 5, 3, and 1, 1. And checking all of the lines, all the other points if they're on that line. 4, 1, and 1, 1. And then 2, 3. So I think we got 3 here. Yeah. So I am wrong. Oh no, we got 5. Wait. What is going on? I'm so confused now. How did we do this? What? We're checking. We take a point, and we take one of the other points, and we create a line. We're checking all the other points against that line. And then we take another point. We're basically taking all of the points back to. Am I crazy? Am I just losing my marbles here? Why do I feel like this is just not going to work the way I'm thinking about it? I think it's wrong what I'm doing. Like, I think even though it might work in this instance, I think it's still wrong. The idea is that if you take a point and it's collinear with some other points, right? All those pairs of points are going to end up with the same point slope if you calculate that. All those pairs. You can use that as a key to a map, and then you can count how many points map back to that point slope form. That works. That's fine. I could do that. We could do that next if I get stuck. Do run into issues when you're dealing with horizontal, vertical lines, but that's kind of beside the point. In that case, you could use another map for horizontal lines, and just have the x coordinate. Yeah, that works, but the problem is that's correct too. The problem is that what I'm thinking here should work too. Why did I think it works this way? So if we take 2 points and we create a line, all the points that are collinear are gonna be on that line, right? So we could just check the first point against every other point. And we get that line. The problem with this approach is that you don't necessarily get every line. Because if you then just take another point and another random point, yeah, you check if everything is collinear on that line too, but you're only checking that line. You're not necessarily checking, the number of lines that we end up checking is only a linear number of lines, where there could be a quadratic number of lines. That's the problem. Yeah, this is not correct. Not correct. Not what I thought. We're just going to use a map. We're not going to get crazy trying to figure out how to an unordered map and unordered set, or just a set. That's fine. All right. Another question is if we have the points are unique. Okay, I was going to say if you have duplicates, it makes it even more complicated. Have to use a multi-set or something. Okay. So now what we can do is say we have okay. How about this? Standard map of standard tuple. We're going to use tuple. This also is taking a while, and this also, it's not the most efficient, but it should be correct at least. It's probably a better way to do this, but we're not going to get into all that. So we're going to map, we're going to actually have a set of tuples. So this is pretty complicated. This is getting complicated. Just call this M, or just say, I don't know. What do you even want to call this? Point map. Point map, okay. Then we have an unordered set, unordered map rather, of same thing. No, this time it's integers. So this is going to be the horizontal, and then also set events. And then we're going to say horizontal. H point map. Horizontal point map. So there's point map and horizontal point map. Okay. So this will be for all the horizontal pairs is the horizontal point map, and all of the other pairs will be the point map. And what we're going to do is this code's a lot simpler. So we have A and B, we have C and D, and we'll say if we have alpha, beta, A is not equal to C, we can calculate alpha and beta, and we can say point map dot insert, or point map of key, say auto key 1 or k1 is going to be make tuple of A and B, key 2, key 2, excuse me, actually key is going to be the slope. So point slope form, yeah, just slope and then the slope and intercept. Slope and intercept, point map of the key, insert tuples of AB, and we'll say key 1, K1 equals standard tuple of AB. So we're going to use that later. Put the K1 in there, and also CD. And I realize we're making lots of tuples over and over again. Potentially. Okay. Otherwise, we're going to say something like the following. So this is going to be the horizontal point map. The key is going to be it's just alpha, not alpha, A. So these we don't need to calculate. You can just say the key is A, and we're going to insert both of these, K1 and so we can say auto K2, C and D. Okay, so this is going to be K1 and K2. we're gonna do this right. So okay. So now, and this is HPT. It should really simplify the code a lot. We don't need to do any of this stuff. This doesn't matter. Okay. So now we have, excuse me, ret equals 0. So each time you insert into either of these, you just update ret and say ret equals standard max of ret and pt map of key dot size, and the same thing over here. Excuse me. And also, it should actually create the set when, if it doesn't exist, when you call this. We're also going to just say auto reference t pt map of key. So it should automatically construct t, or yeah, pt map of key when needed. And so obviously calling this multiple times is calling the hash function to get calling this function multiple times is not efficient. It's technically constant time, but I think you have to calculate a hash or something, so you don't want to do that more than once. All right, so something like this is what we want. Point slope form, and place points into a map using the point slope slope intercept values. As a key. What's the word? Update the maximum number of points. Share. Slope and intercept. Yeah. So something like this ought to work. See if it compiles. Oh, these should be integers also. Yeah, I've gotten that compiler error before. How are we doing on time? Almost an hour. Yeah, it took a while, huh? And this is just A. Compiler error. Oh, this is a tuple of ints. Missed that. I missed that. So these are pretty complicated data structures here. Wrong. 3 and 5. Wait, what? Huh? These are sets, so how did we get... Wait, what? Okay, this one I'm sure should be correct. Unless my logic is wrong. It's interesting that it seems like this worked. I think it just randomly worked before. Hi, hey, how's it going, Melito? Welcome back. Hello, hello. Welcome, welcome. Howdy. How are things? How are you? So we got 5. How do we get 5? What are the at the end of this here? What's the oh no, yeah. So you use the key for alpha beta. This key is the x coordinate. B minus minus D over A minus C, BA DC. So Y's and X's. K2 is C and D. Yeah, that's what it's supposed to be. I think we're doing this correctly. How did we get the wrong answer? That's my question. Where did we get 5 from? Maybe we can print all the values in T. We can do that. 4 const auto x, y in T. Let's do that. Let's say standard C out X, or we'll do it this way. Do this X, Y, and comma with a space. Okay. And duplicate this code across. So what points are we getting here that were wrong here? I thought this is correct. And how's it? Yeah, so Melita, what we're doing, so you're aware, we're trying to figure out if we have a set of points, how many of those points are collinear, and what the maximum number of collinear points. Collinear means they're on the same line. I'm trying to do this efficiently as well. So I think we get the first one correct. Well, they're all collinear, the first one, so we don't really need to worry too much about that one. But the second one is the one that's very curious. Excuse me. So we have 1, 3, 2, 1, 3, 2, 5, 3, 1, 3, 2, 5, 3, 1, 3, 2, 4, 1, 5, 3, 1, 1, 3, 2, 5, 3, 5, 3, and 3, 2. The slope there is, the y slope is 1, right? 3 minus 2 is 1, and 5 minus 3 is 2, so it's a half. Slope is a half. Oh, because this is integers. I'm using integers for the slope. That's why, instead of rational numbers for the slope. Oh, that's why. I didn't think about that. So C++ has a rational class. That's tricky. These are integers too. You could divide by the GCD to get this. You could do that if you wanted to. Yeah, that would still be efficient enough. You just divide both numbers by their GCD and get and actually make that another tuple. So it'd be 3 values for the slope, or 2 values for the slope rather than, yeah. So you could do that if you really wanted to. It may be better just to use a float though. We could try that. So actually, we want floats. Float int. 2 floats. Let's give that a shot. Let's try that. Take 2 floats. Convert these to floats also. So alpha and beta are actually floats. What does this do now? So that's why it's not working. It wasn't working correctly before. Okay. Thanks for the clarification. Yep, you're welcome. Yes, sir. All right. So that seems to work for now. We don't need all of this debug information. Yeah, I was gonna say, it's like this doesn't. Something's not right. Now, I think it just so happened to work before when I was using a slightly different algorithm, but I think you need to use this algorithm. I think the one that I had was not correct. It just randomly selected the correct line, but it doesn't go through all of the possible lines. Yeah. So, I don't know, we need to test some other test cases here. Let's do like a horizontal line. Just see if anything breaks. This is the kind of thing where like a test engine would be useful, so I could just kind of like type in what tests I need and run something. Let's add like 1 1 and 2 2 2 here. Like I could very well run into like floating point errors here or something. I kind of want to go for it. I don't know. I want to beat this 19% though. Yeah, I kind of would need to test like a bunch of different test cases. Let's try something that intersects. Let's do 5 points. And we'll do like, whoops. 1 1 2 2 3 3. Oh, excuse me. 1 1 2 2. And let's say this 2 2 connects to something else. So we'll do. You can do a horizontal line, like 2 3 and 2 1, and then that's it. So we should get 3 here. Oh. I was gonna say, I wasn't expecting that. That was one of those errors that you don't see too often, so I thought it was I'm also blind, so I don't have my glasses on, so I'm very close to the screen. That's good. What about a line that's not horizontal? What could be like, you could do X, but instead of 1 1, you could do 1 3 actually works. So now it's in the negative, the other slope, other direction. And then when you go forward to 3, you go to 3 1, you go down 1. Let's actually copy this and undo. Okay. Huh. Today I had a meeting. Topic was about loyalty. Really? Meeting with whom? At your job or with your friends? What did you meet about? I think I need to submit this. It's already been an hour. It's been a while I've been working on this. We could do, I don't know. No, I don't know, man. I think this is it. I don't know. The problem is the floats. Maybe the floats might be an issue. I don't know. I really wanted to beat the 20%, but I think I need to test more test cases. Oh no! Oh, I forgot 1 point. No. Oh, I didn't even think about that. There's so many. No. Oh, I'm so upset. Oh. Oh, I didn't even think about that. I think if it's 0, but if it's 1, oh, I forgot about that. That's upsetting. Yeah, that might also be why. I think that's probably one of the big reasons why I got 20% is because that case is a very, you wouldn't really think about that. That's why I got it wrong, man. Just 1 point. It was just 1 point. Oh man, there's probably some other test cases too. That's all right, man. That's all right. So you don't get them all. I guess I'll have to remember that in the future. So nervous. It works. Okay. Slow, but it works. Yeah. All right. That's fine. Use a lot of memory. It's slow. And I'm sad. I'm sad. I'm sad. There's probably a more clever way to do this. That's annoying. More clever way that uses less memory and also just needed to get check that one edge case. That one little case. So many things I was trying to take into account too. That's got me in the past before too. That'll always get me. I think if they throw something in there like that where it's just, you expect there to be more than one, at least 2 points, but there's only 1 point. You gotta always check those constraints before you hit submit. Check to see if there's something unusual in the constraints, like only 1 point. What do you do with 1 point? All right, that wasn't too hard to get correct, but definitely we hit submit a few times to pad our score. Oh man, submission rate is low. Yeah, my solution is low. It's slow. I recognize that because we're what's the word? Because I am creating all of this extra stuff, the maps and things, uses kind of a lot of and the tuples uses a lot of extra cycles to do that. Yeah, there's definitely a better way to do this. I think because you're using integers, you could do it in a more clever way too. This actually works for reals in general, I think. Also, this isn't just for like integers. I think if it's just integers, there's some clever things you can do, especially if you know the bounds, which you do in this case. And it's relatively small, the bounds. 10 to the 4th, yeah. Yeah, given the bounds, you can actually, I think you can optimize this quite a bit because of the bounds. All right, anyway, so now I'm sad. All right, that's gonna be it for this one. Actually, you can do yes, you can optimize this quite a bit because you have 10,000 for the bounds, right? Yes, because you have 10,000 for the bounds. What you can do is if you square this, or no, yeah, square it. 100 million fits in the single integer. You can rewrite the two-dimensional array. You can hash your x and y coordinates to 100 million. You can hash your two-dimensional Cartesian plane that you're working with to a single array. So you can hash all of your x and y coordinates to a single number. And then if you can hash everything to a single number, then you can actually use... Now, would you want to use a vector of 100 million? No, that would be too much. Then you can use an unordered set, an unordered map for the for a few things. This map could be just an unordered map, and the tuple would be the same. No, actually, you still want a map with tuples, but this set could be a set of just integers. That could be an unordered set, and then these tuples could be integers, so that could be a little bit faster if you use integers instead of tuples. This would still be the same. This could be a vector of 10,000. That might be a little bit better. So you do a vector of 10,000, that's faster instead of an unordered map. The map of floats, though, I think you're kind of stuck. Well, again, because you're dealing with rational numbers for the slope, I think this also could be mapped. So the slopes themselves can be mapped to a single integer instead of two floats. Instead of a float, and then also the intercept could be mapped to another integer. Problem with that is I don't know if you can combine both of these integers, but you definitely could make this float an integer. I know that's the case. That's definitely true. And then The tricky thing about that though is that you'd have too much memory if you made all of the y-intercepts like relevant here, I guess. Is there a way you can combine these two floats? I know you can make one float an integer. That would optimize things a little bit. I think you're kind of stuck with, yeah, the intercept and the, yeah, you're kind of stuck with the intercept itself is also a double an int. So you could at least have a tuple of ints here instead of floats. And then this would be an unordered set of ints as well. I don't think that really helps that much though. I still think it's like going to be relatively slow. Yeah, unfortunately. Yeah. I think what I was suggesting before, maybe what I was saying before does actually work. The idea was that you get a particular, these values for your floats, and then that's your key, and then as you compare other values, if you have the same thing. The difference though is that I'm keeping these in memory. That's the problem, is that before I wasn't keeping them in memory. I was only looking at them once. Yeah, you need to kind of keep them in memory as a key. You don't necessarily need to make this set. Make this a set. The only reason you want to make this a set is so that it's just easier to do, to think about, to add values to it. Because you kind of don't know exactly when you're going to see. But the reasoning is that when you look at 2 points, the line between 2 points, you look at all the other lines, all the other points. Any point that's on that line is going to right, but the point is that you could end up looking at 2 other points that are on the line in a different like context, something like that. Yeah, that's the idea. And if you're not looking, yeah, never mind. Okay, I understand. No, I get it. I think this is like, there's probably other ways to do this, but this is like a pretty straightforward way. Really interesting problem. Yeah, man, I struggled with this. Okay, that's probably it for the analysis. We can go look at the discussion, but I'm just gonna skip that for now. Loyalty. I met with church members. Oh, okay. What was the context? I don't know what happened. Also, yeah, I realize I'm a little distracted by the problem here and just talk about the problem. Let me restart the stream, make some food, and we could chat. Let's do it that way. I also that was a doozy, that problem. Man, I can't believe that was the only thing I got wrong, was just that one extra. So close. I really wanted that better than 19%. You know, what do we say? We're gonna pad the score by submitting a bunch. I don't really want to submit it too many times because it's the problem is it's such a bad score that I have. It's so much less efficient, but it's fine. It's good enough. It works. Don't need to get too crazy. Really don't need to get too crazy. All right, let me do that. Let me restart the stream. Are you still here, Melito? Yeah, I think you are. All right, let me restart. I'm gonna restart the stream, and what I'll do is I'll just like put a different title and like I'll make food and we can just chat while I'm making food and eating. All right, I'll be back.